Welcome back. Today we're going to be discussing parallelograms. So we're going to start out with the definition, and it's just a quadrilateral with both pairs of opposite sides being parallel. So we use the symbol here, looks like a parallelogram, and then 4 letters since it's a quadrilateral. This is an example of a parallelogram. So we have opposite sides are parallel, so A and B are parallel to C and D, and A and D are parallel to B and C. Okay, so next I have a chart for you that has several different properties going on here. Let me just get that centered so you can actually see all of it. Alright, so the first part of our chart has some properties here. We're looking at the first one says opposite sides of a parallelogram are congruent. So that would be AB, which is AB here, and DC. So the opposite sides are congruent. They are the same length. So then we also have AD, which is this side, and BC, this side, which are congruent. The next property says that opposite angles in a parallelogram are congruent. So now we're looking at the angles. So we have angle A, and then the one opposite of that, straight across, would be angle C. Those are going to be the same size. And then we have angle B, and the one opposite of that, which is D. Those are going to be the same size. Okay. Our next property says that consecutive angles in a parallelogram are supplementary. So that means if I'm going around my parallelogram, one right after the other will be supplementary. So from A, the very next angle is B. So A and B are supplementary. From B, I'm going to go around, so the next one is C. So B and C are supplementary. They add up to 180 degrees. From C, I'm going to move around to D. C and D are supplementary, or 180 degrees. And then from D, I also have A. So A and D are supplementary, 180 degrees. Alright? So then our next property is if our parallelogram has one right angle, then all 4 of them have to be right angles. And that makes sense with this one that we just talked about. Because if one of these is 90, to get 180, the other one has to be 90. So we have this picture down here. So if G is a right angle, then H has to be a right angle, because they have to add up to 180. So they're both 90. If H is 90, then J has to be 90, because they have to add up to 180. We could also look at our opposite angles. If G is 90, J has to be 90 because these are congruent. If H is 90, then K has to be 90 because those are congruent. Opposite angles are congruent. So you can look at this one several different ways and see how it applies. Alright, this next piece is about the diagonals. So we have the diagonals for our parallelogram. They bisect each other, and if you remember, bisecting means that they cut them into equal parts. So QR is equal to QT. It has been bisected. And SQ is congruent to QU. It has been bisected. The other thing we know about diagonals is each diagonal separates our parallelogram into 2 congruent triangles. So if we look at this, we have this big triangle is going to be congruent to this triangle. So we could say triangle URS is congruent to triangle STU. Okay, and that's our congruency statement. And we talked about that when we were talking about congruent triangles. I just wanted to remind you there. So this one we have already talked about. Okay, so let's do a few examples. Alright, so our first example here, we have a quadrilateral, LMNP. It is a parallelogram, so that's important, because all of those parallelogram rules will apply. And we're going to find the measure of angle PLM, the measure of angle LMN, and what is D. So I'm going to write those over here. So angle PLM equals angle LMN equals, and D equals. So we make sure that we find everything that we're looking for here. Okay? Alright, so then how do we actually get started with this? Well, we're going to be looking at the information that they give us. They gave us an angle MNL is 60 degrees, and angle PNL is 42. They also gave us some sides here. We have LM is 2D, and we have PN is 22. So let's go back and look at our properties. I'm going to look at sides first. That's the top one. It says opposite sides of a parallelogram are congruent. Do I know anything about the sides here? I do. I have LM and PN. Are they opposite sides? Yes, they are opposite sides, so they should be congruent. So that means 2D equals 22. So then I'm just going to solve for D, dividing by 2 on both sides, and we get D equals 11. So I'm going to fill that in down here so I have the first piece. Okay, so then let's look at the next property that we have. The next property was opposite angles in a parallelogram are congruent. So I know I have some angles over here. I have these two angles, and I want PLM. So where is PLM? PLM is this big angle here. Well, this angle is opposite of this one, so I know that this whole angle is going to be congruent to that one. So I have 66 plus my 42 equals angle PLM. Okay, so now I'm just going to add those together. 66 and 42. I have 108 equals angle PLM. Okay, so I'm going to go ahead and fill that in over here. This is 108 degrees. The next one is LMN. LMN. That's this large angle. Well, that's not an opposite, so I'm going to go back to my properties and see what I can do with that one. The next one says consecutive angles in a parallelogram are supplementary. So if I add them together, I should get 180. So coming back over here to my picture, these are supplementary. Okay, so I have 108 plus angle LMN equals 180. Those are consecutive angles and they are supplementary. So then I'm going to subtract the 108 from both sides, and I get angle LMN equals 72. So this is 72 degrees. Okay? Alright, let's look at another one. We've answered everything it asked, so we're ready to move on. This next one is using coordinates. Okay, so we have what is the coordinates of the intersection of the diagonals of parallelogram A, B, C, D. So we're going to first graph these on our grid. So we have A is at 2, 5. So that's 2 up 5, and that's A. B is at 6, 6. So we're going to go over 6 and up 6. And this is B. C is 4, 0. So over 4, up 0. That's C. And D is 0, negative 1. So 0 down to the negative 1. And that's D. So I'm going to go ahead and connect these to make my parallelogram. So it says, what are the coordinates of the intersection of the diagonals? So let's go ahead and draw our diagonals. Okay, so we're looking for that point. Okay. Now if we go back to our properties, the diagonals, it says they bisect each other. If they bisect each other, that means that these are equal parts. So this point here in the middle should actually be the midpoint of these diagonal lines. And if you remember back to semester 1, we had some formulas. One of them was midpoint. So here's our formula sheet. So we have midpoint equals, we have x1 plus x2 over 2 and y1 plus y2 over 2, and that's going to give us the coordinates. Okay, so I'm just going to write that down here. So I've got x plus x over 2, and that's y plus y over 2, and then I'm going to end my parentheses there. Okay, so which points are we going to use? Well, let's start here with D and B. Okay, so D and B. Okay, so here's our two coordinates. So we're going to plug those in. Well, I'm going to call B1 and I'm going to call D2. So anytime it says x1, I'm going to be using this one. So we have 6 plus x2, so that's over here, 0, over 2, comma, y1 is 6, plus y2 is a negative 1, over 2 in my parentheses. 6 plus 0 is 6, so this is 6 over 2. 6 plus a negative 1 is 5, so this is 5 over 2. 6 over 2 is 3. 5 over 2 is 2 and 1/2. Okay, so this is midpoint of BD. Now let's look if this even seems reasonable. Over 3, up 2.5. It does seem reasonable. If you want to check, we could also use AC and we should get the exact same midpoint. So if we did AC, I can do 2 plus 4 over 2 and 5 plus 0 over 2. Okay, so I'm going to slide down. 2 plus 4 is 6 over 2. 5 plus 0 is 5 over 2. So this is 3 and 2.5. So we come up with the exact same number. This is midpoint of AC. And we should have the same number, okay, because it's the intersection of the two lines. So it says, what is the coordinates of our intersection? The coordinates are 3, 2.5. Alright, that is all for today. I'll see you in class tomorrow. Bye.